Okay, now this is the next step if you're doing the gorilla data set. As we talked about the TPO and the victims, this is an amazing data set. I already ran it. Let's just do it as death. So you look at death and you have it right there. So what this is basically saying is that there is no statistical significance between fuerza, which comes first, that's like the police and military, guerrilla and paramilitaries. But the problem is, what happens? Interesting. What happens when we want to know guerrillas versus paramilitaries, right? We don't know. So you can do what we call a post hoc test. Post hoc test allows us to do a pairwise test. We pair all these together, see if there's a significance difference between them. So as we already said, fuerza, right, is the police. That's why it's first. It begins with an F. But we're only seeing, right? Oops. We're only seeing the paired between fuerza, because it begins with an F, that's the base, and guerrillas and paramilitaries. Let's see. So we can use this really cool package called Emmeans. Where's my Emmeans? I already have it downloaded. So you obviously know what you do. You have to install it first using quotes. Then you have to get it out of the library, not using quotes, but I already have it. So it's easy. It's actually an easy test. You just go Emmeans, right? That's it there. That's the function. And it'll give you a pairwise test result. See, death. And then you can just say pairwise, and we're using the independent variable TPO, right, to see what happens. See, it comes right up. So this is comparing fuerza to guerrilla, fuerza to paramilitaries, guerrilla paramilitaries, and nothing according to this. Look at these very low T ratios, T values, which the higher, the better fit for your model. That gives us a P value. So that's why these P values are so high, and they're way above 0.05, and it's saying it's not statistically significant. So that's what we call a post hoc test with Emmeans. We can also do another test, which I already did, as you can see. I'll just do it again, death Anova, where we use the Anova function. You can use Anova is good when your independent variable has different levels. Whereas, oh, this is such a big data set, we won't even go into it, guerrilla and paramilitaries. So you have death Anova, we'll call it Anova, that's the analysis of variance. The dependent variable, as we know, is victims. That comes first. Then the independent variable, my bad, is TPO. You know, I like to say data equals so R doesn't get confused. And we do the summary. Death Anova. And we see this F value gives us a general global view of this, and it's not significant. But what's cool about this, right? Can remember this, the degrees of freedom, just to say, I have other videos on this. That's the amount of data points we have, and the residuals, you basically have degrees of freedom, you know, -2, because it's an independent dependent variable. If there were 2 independent variables, it would be 3, etc. Now, really quick, anything with residuals, the smaller, the better fit for your model. These sums of square and means of squares, the higher the better. Notice residuals are incredibly higher than each one, than the sum of squares and the mean square. That's why it has a high, a pretty bad F value. It's just like the T value, the bigger the better. And it gives us a P value. If that was 0.05, we can conclude globally all those together are statistically significant, but they're not, right? They're not. So what we're going to do is do a Tukey test, TUCHSD, and then just put death, Anova, And you have it right there, the same thing. Guerrilla fuerza, paramilitary fuerza, and nothing is significant according to this p-value. So what you're seeing here is that they're all, even though as we'll see, there's a lot more paramilitary deaths than there are fuerza and guerrilla. Regardless, there's more paramilitaries, right? Attacks, but they're lower, so they're coming up statistically not significant. So even though we're going to see later, there's more paramilitary attacks, there's more paramilitaries, generally speaking, in this data, right? We're going to see that the killing itself ratio is not statistically significant. I just did a quick table to show you. Look at Fuerza 170, Guerrilla 340, and look at Paramilitary 1,166. But what it's saying is, regardless of these lower numbers that are in this data set, you're still not being killed, right? Relative to the algorithm that's being produced here, all of the people here are being killed at a similar rate according to the algorithm. That's not statistically significant, meaning one isn't killing more than the others. And I think that's because of some outliers here. But regardless, this is telling us something very important, that maybe civil wars last longer because there's basically a stalemate in the kill ratio. Take care, everyone.